All right, let's jump right in. We're going to pull back the curtain on a bunch of powerful but kind of hidden tools that are shaping our world. Welcome to our deep dive on what we're calling the H-list, a whole collection of really influential algorithms that, believe it or not, all start with the letter H. So, you see words like this, and I get it. It can feel like a total wall of jargon, right? But here's the thing. Try not to think of them as these scary, abstract concepts. Instead, think of them like a specialized toolkit, you know? Each one is built to solve a very specific, very real problem. And to make this super clear, here's how we're going to break it all down. First up, we'll look at how these algorithms are basically pattern finders, making sense of all the data out there. Then we'll get into how we use them to actually build smarter, faster systems. And we'll wrap up with how they help secure our digital future. Sound good? Let's go. Okay, first up, making sense of the world. I mean, think about it. We're swimming in a sea of information, right? It's just everywhere. So this first batch of algorithms, they're like our digital interpreters. Their whole job is to dive into all that noise and find the hidden stories, the hidden structures that we'd never see on our own. So a perfect example of this is hierarchical clustering. You know how a streaming service can recommend a super specific subgenre of music you've never heard of? Well, this is kind of how they do it. Think of this algorithm like a digital biologist. It takes a huge mess of data, say 1 million songs, and starts grouping similar things together. Then it groups those groups together, and so on, and so on, and so on, until it builds this amazing family tree of relationships. And that tree, which has the fancy name dendrogram, literally shows you how everything is connected. And what's so cool is that the shape of your data totally dictates the tool you have to use. For data that has those nested, kind of Russian doll structures inside of it, hierarchical clustering is perfect. But what if your data is just massive and sprawling, like a giant social network or, the entire tree of life? That's when you need something different. And that's where hyperbolic embeddings come into play. They use this really clever curved geometry to map those huge hierarchies with incredible efficiency. And believe me, this sense-making toolkit is huge. You've got things like hidden Markov models, which are the magic behind how your phone actually understands you when you talk to it. There's high-order tensor decomposition. That's a mouthful, I know, but it's great for finding subtle patterns in really complex data, like how people behave online. Then you have something like hyperspectral unmixing. This lets us look at satellite images and figure out exactly what's on the ground, like identifying specific minerals or types of crops from space. Okay, so we've seen how algorithms help us understand the world. But what about actually building things with all that data? That brings us to our next section, the engineering toolkit for making our systems smarter and faster. This is where we really get into the nuts and bolts of modern AI. And this leads me to one of my absolute favorite ideas in this space. It's called Hindsight Experience Replay. Now, this is going to sound a little weird at first, but it is brilliant. So picture this. A robot arm is trying to pick up a block. It tries, and it fails. It completely misses and knocks the block over to the side. Now, normally, that's just a failure, right? But with this algorithm, it looks back and says, you know what? Let's pretend the goal was never to pick up the block. Let's pretend the goal was to knock it over to that exact spot. And boom, the robot just learned something useful from a total failure. And this one little mental trick, it absolutely changes the game for training AI, especially in robotics. See, in really hard tasks where success is super rare, this approach means the AI can learn from every single thing it does. There are no wasted attempts. This radically speeds up the whole learning process because every mistake becomes a lesson in what's possible. It's just a much, much more efficient way to learn. And this kind of optimization, this constant fine-tuning, is happening all around us, usually completely out of sight. You've got hash-join algorithms, which are the unsung heroes making sure the huge databases that run your apps are lightning fast. Then there's hyperparameter optimization, which is basically the art of tweaking and tuning AI models to get every last drop of performance out of them. And H-infinity control algorithms, these are the crucial bits of code that keep complex systems like airplanes and power grids stable and safe, even when things get turbulent. But this engineering toolkit isn't just about making today's systems better. It's pushing us into the next frontier. As this quote says, early quantum advantage is emerging. And this isn't some far-off future thing. We're talking about hybrid quantum classical algorithms, and it's happening right now. Yeah, this is officially leaving the realm of science fiction. The idea here is to combine the mind-bending power of quantum computers with the stability of the computers we already have. And by doing that, we're starting to crack problems that we used to think were literally impossible. We're talking about things like simulating molecules to invent new medicines way, way faster. Or on the flip side, creating tools that could break today's toughest encryption. That's a huge deal. But all of this power, it forces us to ask a really important question, doesn't it? I mean, it's one thing to build these incredibly powerful, intelligent systems. It's another thing entirely to make sure they're safe, that they protect our privacy, and that they actually work in ways that align with what we as humans value. And that very question brings us to our final section, securing our digital future. This is where we talk about the algorithms that are designed less for raw speed and more for safety, privacy, and our values. This is all about building a digital world we can actually trust. Okay, let's start with something that honestly sounds like it's straight out of a sci-fi movie, homomorphic encryption. Get this. Imagine you have a locked safe, and inside is some really sensitive data. This type of encryption lets you do work on that data, run calculations, analyze it, without ever opening the safe. It's mind-blowing. A hospital could let an AI analyze your private medical records to look for diseases without ever decrypting or seeing your personal info. But look, real security is never about just one thing. It's a defense in depth. You need multiple layers. So homomorphic encryption takes care of privacy. Awesome. But how do you know the data hasn't been messed with? For that, you need integrity, which we get from things like hash chain cryptography. Yep, the same tech that powers blockchain. And then you need your systems to be tough, to be resilient to attack. That's robustness. You put all three pillars together, and that's how you build a truly secure system. And here's a really key takeaway. This stuff isn't just about putting up walls or playing defense after the fact. It's about a fundamental shift in thinking. It's about being proactive. It's about designing our systems so that our values, things like privacy, fairness, and safety, are baked right into the code from day one. And maybe nothing captures this idea better than what's called human-in-the-loop optimization. This is all about creating a true partnership between humans and AI. The system is explicitly designed to learn from expert human feedback. So that AI diagnosing medical scans, it might analyze thousands of images way faster than any human could, flagging things that look suspicious. But then the human doctor steps in with their years of experience and intuition to guide the AI, to teach it nuance, and to make the final call. So that leaves us with one last big question to think about. We've gone on this whole journey, right? We've seen how these once hidden algorithms help us make sense of the world, build amazing technology, and even start to secure our future. But as these systems get smarter, faster, and more independent, the biggest challenge we face might not be technical at all. It might be a deeply human one. The question is, how do we make sure that we, with all our messy, brilliant human wisdom and values, always stay in the loop?